Hi everyone, let's apply a sequence of transformations, and this is related to the idea of compositions of functions later in section 1.6. Let's graph something like this. You have the power to do this without having to do too much point plotting. Graph y equals 2 minus the square root of the radicand x plus 3. Let's start at the beginning with a basic function and a basic graph that you know well. Where should we start? How about y equals the square root of x? What does that graph look like? That's our old friend, this hook. Now, different students might approach this in different ways, but how can we build up to this right-hand side here? Again, different students might take different approaches. Well, we could substitute x with x plus 3 and get that radicand. So we go from here to y equals root x plus 3. And when you substitute x with x plus 3, what do you do to this red graph? What happens to it? It's a substitution, so it's a horizontal translation. Which way? Remember, the sign is surprising. X plus 3, you might think right. No, you go left by 3 units. Remember, there are two ways in which horizontal translations are confusing. They involve a substitution and the sign surprises you. And then, what's the next step we can do? Symbolically. We can take the right-hand side and multiply by -1. And what impact does that have on the graph? It takes whatever graph we get here, and then we reflect it about the x-axis. That's what happens when we multiply the right side by -1. Finally, we add 2. And some students might want to rewrite this so that the plus 2 is at the end. That's fine. It doesn't matter. But let's do that at the end. Add 2. Y equals 2, or you could put the 2 at the end. 2 minus root x plus 3. And what impact does adding 2 have to the graph we get from the green? We're going to go up 2 units. So here's what we want to do. We want to take this basic graph we know and love, y equals root x, our hook. We translate it or shift it left by 3 units. We take the result, reflect about the x-axis. We take that result and move it up 2 units. Let's do it. We start with this original Big Daddy graph, y equals root x. That's our basic hook. When we go to y equals root x plus 3, we're shifting left by 3 units. Don't worry about the intercepts for now. And then when we multiply the right side by -1, we reflect about the x-axis, and the graph now goes down from this point. And then when we add 2, we take this graph and move it up 2 units. Now, you don't have to worry about intercepts until the end, but the endpoint we have to care about anyway. We do care about what happens to the endpoint by the end, but we can actually trace its behavior. 0, 0, after we shift left by 3 units, that goes to -3, 0. Now, when we reflect about the x-axis, we call this a fixed point in the transformation. It doesn't change. It stays at -3, 0 when you reflect about the x-axis. And then when you move it up 2 units, it goes up to this point here. It's clear from the way that the axes are labeled that this is the point -3, 2, but it might be good to label it anyway. But at least do one or the other. indicate the ordered pair, or draw the graph and scale the axes in such a way, label the axes in such a way that we can tell where the endpoint is exactly. It's at the point -3, 2. Remember, you have to clearly indicate where any endpoints on a graph are. You must indicate where this endpoint is. As far as these intercepts go, I'll leave that to you. Figuring out why the intercepts are where they are, I will make this comment. 2 minus root 3 is slightly positive. Remember that root 1 is 1. Root 2 is about 1.4. And root 3 over here, root 3 is about 1.7. Root 4 is 2. It's good to know some of these basic radical approximations. So root 3 is about 1.7. 2 minus root 3 is about 0.3. So this y-intercept is just slightly above the x-axis. That may be good to know because you might be curious to know whether the graph is going through quadrant 1 or quadrant 3. It turns out to go through quadrant 1 and not through quadrant 3, though you may not know that until you do some point plotting or figure out where the intercepts are. If you plug in x equals 0, then you can figure out that the y-intercept is at 2 minus root 3, which turns out to be slightly positive. I'll leave it to you to find out why the x-intercept is at 1, 0. Okay, anyway, so we get this hook graph that starts at -3, 2, and that starts at -3, 2, and arcs downward. It extends on forever and ever. Again, different students might do it different ways, but you both have to end up with basically this same graph down here. So we've applied a sequence of transformations, a translation, a reflection, and another translation in order to get this final graph.